Alrighty. All right. Welcome to week two of our party of databases. Any questions from last week? Is everyone cooking today? We had wings made last week. I think, Casey, you were making wings last week. Was that you or was that someone else? I remember. And Danielle's cooking this week. All right. That's fine. It's dinner time where you guys are. It's like 9:30 p.m. where I am, so it's almost bedtime here. All right. So if there's no questions, we can talk about what's going on this week. So this week, we're going to talk about the starting of coding. We're going to talk about the select clause and all the things that go with it, the where and from, and all these good things here. We'll get to those in a second. Again, here are your reading assignments for this week. Again, the book is a cool thing to reference. It's not something you necessarily need to read. Someone mistook what I said last week, saying don't read the book. No, read the book. Just don't like try to sit down and pretend like it's like the Chronicles of Narnia, because it's just there's nothing fun about it. Use it as a reference. Look it up in the back, see what you're looking for, find the page, look at it a little bit, and that's that. If you are good at Google searches or AI, you don't need the book. You just say, teach me this, and it'll teach you that. So do make sure you watch these video tutorials and check the websites, because that is, like I said last week, the problem with the book is that it is static. It doesn't change as opposed to websites that change all the time. So make sure that you are keeping up with the most recent knowledge. For anyone going into a career in IT, the plus side is that it constantly changes and you get to learn new things. The downside is it's constantly changing and you have to learn new things. So it's you got to stay on top of whatever's going on. So okay, so I just want to touch on the writing assignment this week. Like I said last week, every week you'll have a writing assignment. That writing assignment is basically I've hired you to design a database for a dog grooming company. Every week I'll give you a series of instructions on what I want you to do with that database. Every week I'm going to ask you to write the queries that you need to use to do what I asked you to do, and write me a quick excerpt of how you did it. And then there's some questions at the end, like asking you deeper thoughts on the process. The only difference is this week. This week, there is no writing. So this week, I want you to do all this stuff and then make a 3 to 5 minute video that I see you on camera for, and tell me what you did. Explain it to me, instead of writing about it. For me, that's way easier. I don't like typing. I'm not very good at it. As you will soon see as I'm writing code in class here. But also, again, this keeps me from having to force you guys to download Proctorio on your computers. Proctorio is an evil program that's spyware and does bad things. I don't like to put it on my computer. I don't want you to put it on your computer. So if you do the videos for me, we don't have to use Proctorio. I don't need everybody. Inevitably, 3 or 4 people won't do it. Some people do the video but won't put their face on, whatever. Just if you're gonna do it, do that for me. So when they come and say, "Hey, we need to credit your class," I can show them the videos and go, "Hey, I saw everybody." All right. Okay, so then we got the quiz, we got the exercise. Everything's the same as last week. If there are no questions on anything, we're going to start talking about this week's assignments as soon as I'm out of there. All right. So I told you last week that there were two basic kinds of queries. There was DDL and DML. DDL is data definition language. Definition language, and then data manipulation language. Okay. Data definition language are the code, the commands that you run to create the database and all the objects in the database. Data manipulation language is the code you write to manipulate the data in the database. Like I said last week, this is all in plain English. So let's look at a couple things real quick. And so today, what the bulk of this class is going to be is me just walking through code examples, and they're very rudimentary. If you've done databases before and done the code before, it's very rudimentary code. But I'm going to talk about some deep dive stuff about how it does things in the background, and then we're going to talk about just the mechanics of how the queries work. So the first command is this show command, and then it's just show databases. Over here, I've got all my databases, but if I want to do it in code, this does it. It's a simple command. Just shows me all the databases that are my data thing. Whenever I want to use a database, before I can write a query, run a query against anything, I've got to write this use command, and it says which database I'm going to use. And then, we'll use the Sakilla database. This is the one that you'll be using for your exercises, the Sakilla database, and Possum Pets are what we're using for your writing assignments. If you want to see what tables in your database, you write the show tables command. And then if you want to know about the database, which table, you write describe actor. And when you describe, it tells you the column name, the data type, whether it's null or not, if it's any kind of key, and if any default settings or any other extra things like auto increment. We'll cover that in a second. The basic, so let's go down here to DDL. I want to create a database. This is very difficult. I do this. It's a database. And I refresh over here. And look, there it is. So create database. This is a fun one here. If not exists, basically says if the database doesn't exist, create it. If it does exist, let me know that it exists. And then it's called week 1 practice. That's all I've got to do to create a database. Nothing more, nothing less. I want to use that database. And I want to create a table. So my command to create a table is create table. And then here I put the name of the table, whatever you want it to be. It can be plural, it can be singular. It's your table. You call it what you want. Just make sure it's got a name that makes sense. There are companies that make proprietary databases. And what that means is it's a database that only they're allowed to use. Only they don't want anyone in there messing around with it. And they'll name tables like this. And that's the name of the table. Oh, sorry, _1. Because they've got the code of what it is, so they can translate that to like people, but they write it that way. So if you ever run into a database and look at that, it's proprietary. They don't want you to look at, which makes me want to learn about it even more. So I've done that a number of times. I've made a lot of vendors mad at me at work when there's a problem with their database and they've named everything all weird ways, and I figured out what it was and I fixed the problem for them. I think they were mad then. Wait till they saw my bill. All right. So create table heroes. Hero ID. That's the first column. Always have an ID column in your table. That is the standard indexing column. And it's like 1, 2, 3. It's whatever you want it to be. So this is the standard column in everything. Every column should have an ID. It should be the name of the table _ID, just for clarification, so you're not confused what it is. Int is the data type. That stands for integer. Next week, I'm going to do a 15-minute sermon on data types. Just so you know, be prepared for that. I love data types. They're very interesting to me, and we'll talk about them in great detail. I don't have time for that tonight. Int is an integer. It means any positive or negative number between, I think, like 25 million, positive 25 million, negative 25 million. So it's a fairly large range. Auto increment means it will number itself. You don't have to number the column. It'll just auto number. You just insert into it, the number's there. Primary key tells you that this is the most important column in the table. It's the one that's the basic index. Primary keys can be up to 3 different columns. So primary key doesn't only have to be 1 column. It can be up to 3. A lot of things I'm going to bring up tonight. We're going to talk next week. I'm going to design a database with you guys. We're going to do it from scratch. Just build it out for fun. And we're going to talk more about how the primary keys work there. I just want you to understand that a primary key is the most important key in the table, row in the column in the table. It tells you how to basically organize the table. Then I've got hero name and hero real name. That's varchar. That means variable characters. That means this name can be up to 50 characters before it throws an error. If you try to do 51 characters in there, it'll throw an error. Not null means that this column must have a value. Okay? Real name varchar 50 can be null. Right? I run this code. It builds the table. I describe the table. And it shows me everything I said was going to happen. Table's made now, right? I forgot to add a column. I forgot to add a column called power level. Alter table heroes, add column, power level, integer. And it's there. Okay. Describe, create makes it happen. Alter changes it. Let's put some data into here. I'm going to put 2 columns in here. I'm going to put one for Superman, one for Batman. Superman, Clark Kent, 100. Batman, Bruce Wayne, 20. Now, I'm going to comment this out here. Okay. So I can normally run an insert statement just like I don't need this part here. I just say insert into heroes and then the values. But if I do that, the number of values have to match the number of rows, columns rather. So if I try to run this, it's going to throw an error. Let me pull the error number here. Get out of my way. There. Column count doesn't match value count. So I've got 4 values, but I saw 3 column values, but I've got 4 columns. So if these don't match, it's going to error out. What I can do is I can specifically say insert into these columns. Okay. So Superman goes to hero name, Clark into real name, and power level goes 100 goes into power level. Notice ID isn't here, right? So the 4th column, hero ID, since it's auto increment, will be automatically filled. You don't need to put a value there. If you do put a value here, which you can if you want, that's going to be the starting number. So if I put the number 100 here, 100 here rather, the first number in the column, the table will be 100 and go 101, 102, 103, 104 from there. But it's just going to start from 1. So I'll insert these 2 columns, 2 rows rather, and I'll do my select statement. And look, they're both there. I do tend to go fast while I'm doing this, so if I go too fast, please someone stop me. Because I don't want you to get confused if I start talking too fast and you're not following, which no shame in that. This can get confusing, particularly when we get to the next part. I was wrong. Superman's power level isn't 100, it's 110. I'm updating heroes. I'm setting the power level to 110, where the hero name is Superman. We're going to go to we're going to dissect these in a second. This is just general understanding. And I do select from heroes. That is changed. I can delete Batman if I want to. He'll be mad, but I'm okay with it. Select from heroes, it's gone. And then I can drop everything. Drop means get rid of it. Drop the table, drop the database, and they're both gone. Does that make sense? Is everyone with me? Okay. Now, we're just going to talk about the select statement. The select statement is arguably the most important statement you're going to learn to write, because that is how we pull the data from the database. Having the data in the database is all fine and good, but it doesn't make a difference if people can't get the data out to see it. So there are 3 basic commands in a select statement: select, from, and where. Select says, go get data for me. From says, here's where the data is. And where says, get rid of everything but this. So Title equals Academy Dinosaur. I run that, and it gives me what I wanted. It's very simple. Let's complicate it. Here, right there, that little equal sign, we can change it into a number of things. So the where clause is our filter.
I'm not sure if your mic is working, Dom.
Okay, hang on a second. Am I back now? Can you all hear
Yeah,
me?
I can hear you.
Hello? Yeah, I'm green. Can you guys hear me? Good. Okay. So what I was saying was John chat should Batman have a hyperbole Superman? And I said that's a fighting statement, and I'll meet you up back for that conversation. That's not cool, man. All right. So the where clause tells us how to filter the data. So here, I just want where the title column is and it equals Academy Dinosaur. Here, I want to know where the rating. If we remember back to second grade, the alligators kissing is does not equal. Do y'all call them alligators kissing? Is that still a thing? Because I went to elementary school in like 1975. So I guess we had kissing alligators back then. I don't know what you'd all call it. But here, this means show me where it does not equal G. So here's everything does not equal G. Here I've got select title and rental rate where film rental rate is greater than $4. Now notice here the value is in quotes, and here the value is not in quotes. Because here I'm comparing it to a string, and here I'm comparing it to a number. Numbers don't need quotes as long as they're not in strings. Is the font too small for you guys? Can you see that? Good. Okay. All right. So here I'm selecting title rental rate from the film table, where the rental rate is $4. And so here, or greater than $4. Okay. We're going to flip it around and show me where the film length. Yes, John.
I've noticed some people like
Hang on a second. 1 second.
don't do their statements in all caps, and they like hit a return for
Again.
each new statement. I'm wondering if that's is that just preference to like for easier readability, or is MySQL case sensitive?
What'd you say?
So, like your select from where, do those have to be in all caps?
No, no. I do it in all caps just because it helps me tell the difference between the commands and the actual words, but you don't
Okay.
have to. It's just personal preference. And when I'm typing code and I'm paying attention to it and I'm trying to make it pretty and stuff, I do it that way. When I'm just in a hurry to write the code, I don't bother capitalizing. So,
Okay, so it's not case sensitive and you don't
no.
have to hit return for each statement because I've
Mm,
seen that too. Okay.
mm. So when the semicolon is what tells you it's the end of the transaction. So yeah, and this is something we talk about later, but every time we run code like this, it's considered a transaction. You can have one command or 3,000 commands, but it's considered a single transaction. All right. So here, select title length from film where length is less than 50. So we're looking for short films. Okay. A little more complicated here. We can use the command between. So select title replacement from film where replacement cost is between 15 and 20. Okay. Now we can also do, so here's the thing here. We've got between, so we're doing here, select title rating from film where rating is in PG, PG-13, and NC-17. So now this is returned an array. So if I have multiple values, then I can say, instead of saying equals PG, I can do where it's in PG, PG-13, or NC-17. Because here I had where it's not equal to G. This is going to be the same response, right? But I have here where I say in. So I'm going to say, find me where this column is one of these values using the in command. And because everything has its opposite, I can throw the word not here and show me stuff that's not in there. So it's going to be G and R. Okay. Show me where store ID is not in one. Did I do one here? Okay. Let me take one digression here. So these are what I refer to as static queries because it's always going to be the same, right? Unless I go in and change it, this is never going to change. So it means whenever someone runs it, the response is always going to be the same. We can create a dynamic query by doing something like this. So here, I put a select statement in here. Select rating where film ID equals 4. And if I run that, and there's a film ID 4, it's G. So now when I run this, it's going to show me all the ones that are not G. Okay. So this is referred to as nesting a query. I can nest a query within another query to get a non-static result because I have, well, this is still kind of static, but I can have it to where that's not a static result. I can have multiple changes in there, like where, something like that. So we'll get to that in a second, but I just want to show you can nest these queries in here. All right, everyone with me so far? Still doing good? All right. Now I've got like here. So let's say I'm looking for something and I know it starts with these 3 letters, but I don't know the rest of it. So I'm going to find everyone whose first name begins with the letters DAN. Okay. So what this does here, it says like, and then I've got DAN and then the percent sign. Percent sign is a wildcard modifier. So it's going to look for the letters DAN and then doesn't care what's after that. As long as those 3 letters there, it'll be fine. Here I've got the opposite where title is like percent sign graffiti. So I don't care what's in front of it as long as it ends in graffiti. And here, select address from address where address like. I don't care what's before it or what's after, but somewhere in there, it's got to have the word way. Parkway, Hanoi Way. So we got all these ways here. Okay. I can also throw a not in front of this. So maybe show me where it's not like way, which is going to be a whole lot more. Okay. The percent sign is only one of the wildcards that we can use. I can always use an underscore. Okay. So what this means, it represents exactly one random character. So here I'm going to say, show me where the first name is like A and whatever the next two letters are. I don't care. But there's nothing there because there's nothing that's exactly three letters. Because this says I want exactly three letters. I want an A and then two letters after it. If I add a percent sign here, all of a sudden I got more responses. So now it starts with an A. I don't care what the next two letters are, but I want to see if there's something after it. Okay. Everyone still with me? So I can do let's see. Oops. Select title from film where those are bad typing. Where title like um A underscore V underscore percent. I don't know if anything's there like that, but I think there might be an adventure or something like that. Yeah, so there's nothing there. But see, I can do it shows me it has an A. I don't care what's next, but the second letter has to be a V. I don't care what's next, and then whatever's after that. So when you guys are asked to write select queries, and you will be asked to write select queries, um, this is how we start getting really granular and trying to find the values that we're looking for. I also have the option of looking for things that are null. So the term null is different than empty. Because if if my cell has a space in it, it's not considered empty. It looks empty, but it's not empty. So we'll come up with it. It won't be. So it'll come up as if I say, "Show me where it's not null," or when it's null, that won't come up. So null means there ain't nothing there. It's completely empty. It's never been. It's pristine. Nothing's there at all. So select where it's null. These show me where it's null, and you get the little null statement here. Um, quick conversation on nulls. Nulls are useful. You can make columns null. Just be very careful when you make a column null because when columns are set to null and you try to put an index on them, your response, your searches will 10% of the time or roughly some of the time be wrong because nulls mess things up. Um, so an index is what it sounds like. Um, it's just a object on the table that sorts the table so you can search it faster. Okay. All right. Moving on. Select title rating length from film where rating equals G and length is less than 60. So now I've got the and command here. So where it's G and its length is 60, which means both criteria have to be met for it to work. So if I run it, they're both there. If I do or, it's one or the other. All right. So I'm going to go here and do order by title. Okay. So we talked about select from where. We didn't talk about order. So select is tell me what to get. From is where is it from. Where tells me how to filter it. Order tells me what order to put it in. So if I run this, it gives me the rating and where the rating is G or PG, where the rental rate is greater than $4, and I'm ordering it by title. Does everyone understand how these work? This is fairly simple stuff? Okay, let's talk about the interesting stuff. We look at this code and we understand it. The computer does not understand this code. The computer does not speak English, it speaks machine code. So whenever we run a query against the database engine, it compiles it into machine code and it saves it internally to run it again whenever you need to do it, right? So we have four clauses here. We've got the select clause, we've got the from clause, we've got the where clause, and we've got the order by clause. So my question to you is when this runs and it's converted into machine code, which is the first clause the engine runs? Is it select from, where, or order by? Yeah, 25% chance of getting it right. I'm going to take a drink while you think. Which does the computer run? Which does the engine run first?
Is it from?
It is from. That is right. So here's what happens. All the data in the database is stored on the hard drive. All right. Things on the hard drive cannot be touched. They can't be looked at. They can't be manipulated. They can't do anything. They are statically stored in that hard drive. The only way that you can get or you can read any data that's on the hard drive is to take it from the hard drive and put it into RAM. So whenever you're manipulating data, even with a simple select statement, it has to be brought into RAM. Okay. Everyone know what RAM and everyone knows RAM and everything? We all good with that? All right, just making sure. All right, so when the query runs, it has to run in such a way that it gets the data that it needs off the hard drive and into RAM. The first thing it has to do is get all the information from the table or tables that are there. So the first thing that is run is from film. So it pulls all the data from the film table into RAM. Who here has 32 gigs of RAM on their laptop or device that they were on? 16? 64. Okay, 16s? And we got 64? Nope. Okay. So think about this. A table, let's see, the largest table on the databases in the company I currently work for is somewhere around 2.5 terabytes. I have one eyebrow raised because they realize, like, whoa, that's a big table. It's a huge table. Tables can get extremely large. Um, that's why we've got to be very careful when we write these queries, because if the film table was a terabyte and I tried to do something select from the film table onto my laptop, it would try to take up a terabyte of space, which it can do technically if you know about file swapping, but that slows down performance. So next week, when we talk about data types, I will give you part of that sermon is be careful of the size of your table. So the from clause pulls all the data from the table or tables off the hard drive and into your RAM. What's the next one that runs? Where, from, select where, or order by.
We select.
The sort? Not sort.
I'm
It's not order
sorry,
by.
I
It's the where
misheard you.
clause. The where clause runs second.
Hmm.
And the reason why that happens is because it wants to get all the information it doesn't need out of RAM as quick as possible. Right? So if it pulls 10,000 rows from that table into RAM, but it only needs 105 of them. It wants to get rid of them as soon as possible. So it pulls in everything, and then using the indexes, it determines what rows can go and then gets rid of them. Okay. So again, let's touch on indexes real quick. I don't normally talk about indexes this early, so this is the first time I've done this, but talk about indexes. So indexes are objects on tables that sort the table in a way that the query can read faster. Okay. So let's look at the film table here right here. Okay. When we look at the film table, we see that it's ordered by the film ID, like I said, because it's the primary key. The primary key is the primary index. It's how things are by default sorted. The title it's accidentally um, alphabetized because they just input it everywhere, but the language ID isn't, right? The ratings aren't ordered. So if I were to try to write a query, so when it writes a query, it starts at row one and works its way down if there's no index. And it works its way down what I refer to as R bar. It's a RBAR, it's a row by agonizing row. So if I say where rental rate is greater than 4, it's going to go through every row one at a time going, yep, nope, nope, yeah, nope, no, yep, nope, nope. And if you've got a million rows in that table, it's going to take a long time for that to do, right? So when you have an index on the table and you've got this where clause, it finds where the 4 is and then finds where the 4 stops and gets rid of everything around it. I'm sure all had the experience of looking at the index in the back of a book. If you're looking for, if you got a book on dogs and you're looking up Cocker Spaniels, you go to that section of the index and find it. You don't have to go through the book going, nope, 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 until you find it. So back to what I was saying originally, the where clause filters the data so that's all that's there in RAM. The next that runs is the select query. Oh, no, sorry. The next one is actually the order by. And the reason why it's the order by, it's because what's in the order by may not be in the select query here. So I'll show you what I'm talking about. So I've got this, I ran here, got that. Let me run this again. All right. Um, I'm going to sort this by rental rate. I'm going to sort this by rating, right? So the same thing does this. But now I'm going to take rating out of the select query. It still sorts it by rating. We just don't see what the column was being sorted by. Okay. So from is first, where is next, order is then, and then the final is the select. That's how it's run. When there are more commands, it does other things, and we'll get into that when that happens. But that's the gist of how the query works. I feel now I'm going to talk about something that I don't normally talk about until week 6 because this is a good time to segue into it. So bear with me here. We're going to deep doctrine. All right. So I keep talking about how a database is an engine. I keep saying the word, it's an engine, it's an engine. All right. It's because it's always running in the background. Okay. So here's your database. Let's get fancy. There's your database. Where's my eraser? That is actually the physical what the database looks like when you're doing a diagram of it. And then we have this is a laptop over here. You're not doing what I want you to do, but you're fine. That's my laptop. Okay. So that's my query. I run over here and say, give me this information. And the database then sends it back to me, right? Okay. Let's say I make changes to the database. So I make the changes here. I make the changes to the data that are in RAM. I'm not making changes to the actual database, right? Just whatever's in RAM because I can't touch what's here. I can remove and I can add, but I can't physically change it. So I make changes to the database and then I send those changes back, right? Okay. And the database is changed. What happens if I'm updating 10,000 rows, right? And I send off the query, and about halfway through, I lose my connection. And the other 5,000 don't make it to the database. That's bad, isn't it? Okay. So what we have now is called a corrupt database because changes have been made, but only halfway. Hopefully this doesn't go too far over y'all heads because this is a key thing to keep in mind for a lot of things. Okay. So I sort of lied to you when I said the database, that laptop talks directly to the database. It's sort of true, but it isn't. So when I run a select query, I talk directly to the database and say, give me this stuff, and he gives me the stuff, right? But whenever I make changes to it, I don't write directly to the database. I write to something called a transaction log. Okay. And even when I say I write directly to, I do direct to the database, everything I ask of the database goes to the transaction log. Okay. So if I'm writing a select query, it goes to the transaction log. The transaction log records what I've asked and then asks the database for that information and then sends the information to me. Okay. If I make a change to the database, I send those changes to the transaction log. It records those in the log and then sends the changes to the database. Do you see where this is safer now? We have someone in the middle. Okay. So I'm updating 10,000 rows. I hit the send button. It sends the 10,000 rows one row at a time because databases do everything one row at a time. It's always one row at a time. So it sends those 10,000 rows one row at a time to the transaction log. And the transaction log starts writing out those rows one at a time, one at a time, one at a time, one at a time. And then it reaches a point where it's okay, I've got enough. I'm going to start sending the data over to the database. Okay. Each row that's entered in has something called an LSN, which is a log sequence number. So every row that's recorded here has this LSN. The first thing the laptop tells the transaction log is here's the starting number and here's the ending number. Okay. So it's, hey, transaction log, I'm going to send you data. It starts with LSN 1 and ends with LSN 5,000 or 10,000. And and the log goes, great. We have 10,000 rows incoming. That's awesome. So when it reaches a point, and it's buffering, y'all know buffering because you're all on YouTube. It reaches a point, it starts sending the data over here because it doesn't want to hold everything here. Starts going here, starts going here. So let's say it buffers at 1,000. So once it hits 1,000 rows here, when 1,001 hits, 1,001 goes here and 1,001. Nothing leaves the transaction log. It's always there. It keeps track of everything. Now the power goes out. and we lose connection. And the database gets shut down and gets rebooted, comes back up. When we were just writing directly to the database, it comes back suspect. I have no idea what's going on. There is an insert going on. The world's over. Just put me to pasture. Now what happens? Database comes back up, says, "Hey, someone was telling me something. I forgot what it was. Hey, transaction log, what's going on?" The transaction log goes, "Hey, we were giving you 10,000 rows. We stopped at LSN 5435. What LSN do you have?" And the database goes, "Oh, I'm sorry. The database, rather, the database says, "Hey, I stopped at LSN 5245. What am I supposed to have?" And the log goes, "Okay, we had 10,000 rows incoming. You stopped at 5235. I have the rest. Let me give them to you." So when it comes back up, if everything had already buffered the transaction log, even if it had been shut down for 3 hours, when the database comes out, it completes that transaction, and all 10,000 rows are there. If the database comes back up and says, "Hey, what happened? We're at LSN, blah, blah, blah. What do you got?" The transaction goes, we were supposed to send you 10,000. We only have 9,643 of them. We're going to erase everything. So what the transaction log does, it undoes everything that was done to the database that was corrupted because of the power outage. And it rolls all those changes back to the time before the power outage occurred. So databases, very realistically speaking, are self-healing. So we shouldn't have problems with outages and things like that. Does that make sense? Okay. So when we look at our code here, and when I say this is a transaction. So when I run it, this is what gets recorded to the log and then sent to the database and then sent back. There's only one command. So back over here, let me do this again. Um, when I had this here, right? When I said delete from heroes, if I delete from a table and I say I want to delete 10,000 rows, again, it does it one row at a time. Boom, 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 boom. Just one, it just deletes one at a time. So it takes a long time. There's a command that we don't really ever want to use, and it's called truncate. Truncate, for all intents and purposes, flushes the database. It just takes everything out of it at once and it's gone forever. It's when I look at my transaction log for a delete statement, when you look in here, you'll see delete row one, delete row two, delete row three, delete row four. So technically, if someone comes in and deletes 15 rows of my database and they weren't supposed to, if I know what I'm doing, I can go back into the transaction log, get those rows, and put them back. Because the transaction log recorded every delete that happened and who did it and when they did it, but not why. That's what we've got to ask them. Truncate doesn't get logged. So truncate just erases everything at once. So that's bad if you didn't mean to do it. Okay. So the mechanics of the database, and this is why I find databases so fascinating because of the mechanics behind them. This transaction log is constantly running. It's always there. Everything, unless you flush the log on purpose, everything that's ever been done to this database is in that log. Um, so, and this goes beyond the scope of this course, but you can go into that log and find when people did things, if they did something they shouldn't, who dropped the table that was supposed to be there, or I created a table, I forgot when I did it, when did I do it? The log is a very valuable thing, but it's there whether you want it to be or not. It's just built in and it's always running. All right. Is there anything that I forgot to talk about? know my select statements. I did how the orders go. I didn't go into I didn't digress into data types because that's next week. That's a fun conversation. For me anyway. Did the ors, knots. Yeah, I think I covered everything. All right. Do y'all have any questions on this week's stuff?
I got a question.
Go for it.
As far as privileges go, are a lot of these commands requiring root privileges, or does it fluctuate between the commands?
So that's it. It's not on the commands, it's on the objects.
Oh,
So,
so you have access to different objects.
right,
Okay, gotcha.
right. So in a broader sense, like in a production database with a lot of tables, right? If we've got 50 or 60 tables, not everyone gets access to all the tables. So each table I can give permission. Bob can go to this one, George can go to this one, Sadie can go to this one, right? Root has access to all of them. Root can do what it wants. Um, which is why we never let anyone have the root password. It's against the law. It's like outer darkness for you if you do that. No. Um, but yeah, it's an interesting question because we don't really get into the security aspect of things. But when you design a database and you get that schema there, you start giving people permission to the tables they need to for what they're doing because not everyone needs access. And you can so you can deny someone insert access on a table. You're only allowed to select, or you're only allowed to insert, or you're only whatever it is. So it can get very granular on things. You can't
So
say, hmm?
like the equivalent of you can only read data, you can't write data or
Yeah.
modify it. Okay.
Hmm. Yeah. So you can give someone read only access to a database so they can't do any changes. And they can go and get granular. Well, you can update this table or you can make changes to this table. And can you change the data or can you actually change the structure? Can you add columns? Can you drop tables? So it's a whole there's a whole choreography to security that goes along with the choreography of creating database objects, which is the topic for it's a fun thing to do. You get a little power crazy when you can start taking permissions away from people because I will deny. So when you're in a don't ever do the things that I do sometimes because you'll get in trouble. I get away with it just because I'm cute, I guess. So if someone breaks something, you can immediately go in and change their permissions. It doesn't require them to relog in. So a lot of times with like if you know what Active Directory is, if I change someone's permission to the entire network and give them access to a folder, they've got to re-log in to get the permission back or to get away. So like if I have a folder that's shared for the classroom and you're using Active Directory to get to that, if you're logged in, I give you permission and you didn't have before, you can't get that permission until you re-log in. It's got to reset. It's got to recreate that object. In databases, if it takes someone's permission away, it's immediate. So they can be in the middle of something and I turn it off and it makes people mad. Um, have I done this before? Absolutely. Is it because they were doing something and breaking the database? Yes. Um, you also have the power to take databases offline as root. If I go in here, I don't know if I can do this here. MySQL's like the baby brother to Oracle. So you can take a database offline and it stops working. I have done that in the past because I didn't know who's using a database. What's the easiest way to find who's using a database? You turn it off and see who complains. Within 5 minutes. Where'd the database go? I don't know. Let me look. Oh, it's there. Maybe you did something wrong. It was a network problem. That's what it was. So, that's just my funny way of saying permissions in database are a very interesting topic, and how you do permissions is almost as important as the objects you create. You can give access to a table except for one column. If there's if you've got an employee table and there's a salary column and you want anyone looking at that, you take away permission to that. You see everything but. So, like I said, it's not something we talk about here. And it's not super difficult to do, but it's all manual because you can't just right click the table and give permission. So you got to write the code to do it. Table inspector. Yeah. So yeah, but yeah. So that was a long answer to a simple question. So I'm sorry. Any other questions, comments, thoughts, book
I was just wondering
recommendations?
if we can have access to this file that you've been going through.
This code?
Yeah,
Oh yeah,
just to go over it
I'll put in the
later.
announcement.
Okay,
I'll drop it in the
awesome.
announcement.
Thank you.
Yeah. And if I forget to do it, just remind me. Yeah, I'll just put it in the announcement because this is code that I wrote to do this with. So I'll just drop the announcement. But the best way to do learn this coding is just to play with it. Like I want to, if I want to see what customer from what country rented the most PG movies and write that query to make that happen. But yeah, I'll send this up. What I'll do is what I normally do is I'll put the video link and then I'll do the transcript and then at the end of the transcript I will drop this code. And like I said, if it's not there, yell at me and I'll put it there because I'm forgetful sometimes. Anything else? So Danielle, how was your cooking? What did you cook?
I made banana bread.
Ah, banana bread. Excellent.
Yeah,
You ever put like a streak of Nutella through the banana bread?
no, I haven't.
Oh, yeah, that's I do that sometimes when I'm feeling particularly Nutella-y. But yeah, I love making banana bread. All right. Who's cooking next week? So we had wings last week, had banana bread this week. Someone's got to do like something, I don't know, maybe grill a steak or something. Well, y'all were it's snowing, so all right. If there's nothing else, thank you for joining me tonight, and I'll see you guys next week.
Thank you.
Bye bye.